Right, I'm going to just explain a little bit about this centrifugal fan arrangement and how it basically works, because most people probably don't really understand why it does the things it does. But so you've got we've got a circular fan assembly, and this is the entry hole where the air basically comes into the middle, and the fan blades are basically shaped like this. They're actually spiraled. So what happens is, as the air is entering the central hole, the air is basically travelling in an inertial force of actual force from outside into the centre of the fan. But because the air is not spinning, it's actually inertial forces have to take place. So as the air enters the fan blades, it has to accelerate in the direction of the blades. So the actual air itself has to accelerate. So as it's entering these fan blades, the fan blades catch the air, accelerate the air, centrifugal forces take place, the air is thrown outwards, right? Now as the air is moving through, it will slow the fan down, which is what happens, because the air is moving in, and constantly fresh air is moving in, and it has to accelerate by the action of the fan blades on the air coming in. So, why does it speed up when we block the air intake or the air outlet? Well, that's because when you block the air intake or the outlet, the actual air is no longer moving into the fan arrangement, fan blade arrangement. So the air is basically static. So the air that's already in the centrifugal fan arrangement is basically the same air per cycle or whatever. So it's already spinning. So there's no longer any work to do. So the fan blades can't bring in any fresh air that's static, that's not actually spinning. So it will accelerate. So the actual fan will accelerate. Now the trick is, now let's say we've got a few of these. Let's just draw the profile, the side view. Right, that's the side view of this. And let's say we have another side view of this, and another one. Right, so we've got three. Let's just do three. So let's say the air is coming in on the first one. The air is thrown outwards, and then we have to direct that airflow in such a way that it doesn't decelerate. Because if we decelerate the airflow so it's no longer in a spiral, we actually have to re-accelerate it again on the next blade, which means we're going to do more work. So let's look at it from the front view again. So what we need is, instead of having, this is the one that's rotating, remember, this is, this is spinning in this direction, right? So this is spinning clockwise. So what we need is a static plate. So we have a static plate between this one, that's this one, and this one. So the static plate, I'll draw it above here, right? So a static plate above there is in between these two rotary systems. The static plate would consist of another arrangement, but instead of having the fan blades like that, we would we want to inset that rotary air. So the air is spinning. It comes out of the first blade. It's running around like a trough that goes around the blade, like an air trough, so it can continue to spin. The air trough will basically guide the air into another assembly, right? So there's a hole, but it's on the back side this time. So there's another assembly with the blades also angled like this. So the air would then be funneled, still accelerating, but the centrifugal forces will keep the air around the perimeter, but we need to direct it inwards. So we'll direct the air back to the center of the point where the next rotary system. So this is this one I'm drawing. So this is static, right? So that's air static. So the next rotary system, we need that air to be funneled back to the center core so that the next rotary system which can take that air in, right? So it's already spinning basically, so we don't have to re-accelerate it. That's what the problem is. That's what we need. Well, not really a problem, but that's what we need to do. We need to try to keep it spinning so that as it enters the next hole, the next intake hole, it's already accelerating. Now, what happens when you actually have something spinning on an external, like a piece of string with a weight on it, and you pull the string shorter? It actually accelerates, doesn't it? As it's rotating around a larger circumference, and you shorten that string, it will accelerate. Well, that's great, because we want it to accelerate, because we want to accelerate into the next suction, so rotary system. So it doesn't have to accelerate at this time. Instead, all we're going to do is gain on centrifugal forces. So we're gaining centrifugal, we're gaining speed on the air. But it's important that we have a stator plate. This is a stator plate, right, with another set of these fins directing the air in, so the air is really spinning really, really fast, and it enters the next one, then goes on, and then we do this repeatedly on a series of rotary systems, so that we have basically no longer have to accelerate that rotary airflow. All we're doing is adding extra centrifugal force to the air coming out, and that increases the pressure on the output. So we have much higher, we have 3 times pressure coming on the output. Anyway, I thought I'd just explain that, but that's basically my idea. But we have to design it in such a way that we're not going to lose, we're not going to decelerate the airflow. The airflow needs to be maintained in acceleration